Nearly 2,000 years ago, Rome built a stadium so vast it could hold 50,000 people in the heart of the empire without steel or engines. It was engineered to outlast chaos, yet today a giant section is missing. Why did this symbol of imperial power survive everything but fail where it did? The answer uncovers how ambition, material choices, and disaster collided to reshape history. In the years after Nero's downfall, Rome's new rulers faced a city scarred by fire, debt, and suspicion. The Flavian emperors needed a gesture that would erase memories of chaos and prove their grip on power. They chose spectacle on a scale Rome had never seen, an amphitheater planted not at the city's edge but at its very heart, right over Nero's private lake. This was no accident. The site transformed imperial land into public space, making the Colosseum a daily reminder of who held Rome together. With room for 50,000 people, the arena became a stage for unity and control, where emperors could offer bread and games to a restless population. Every arch and tier broadcast stability, turning architecture into a tool of legitimacy. The urgency behind this project was more than pride. It was survival, and it demanded resources and organization at a level Rome had never attempted before. Quarry crews east of Rome worked the Tivoli hills, cutting pale blocks of travertine from pits that reached 60 meters deep. Each block was shaped for a specific job. Some were destined for the Colosseum's outer shell, others for hidden supports. The volume was staggering. Over 100,000 cubic meters of stone would be needed, enough to build a solid wall around the whole city. Moving this material required precision planning. Workers loaded blocks onto wooden rafts and floated them down the Aniene River to the Tiber, using the current to carry the weight that wagons could barely manage. When floods or low water blocked the rivers, teams switched to the Via Tiburtina, hauling stone overland with oxen and carts. Standard shapes and sizes made stacking and assembly faster, turning construction into a routine rather than a gamble. Every step relied on coordination between quarrymen, transport crews, and site teams, all synchronized to keep the flow of stone uninterrupted. At the Colosseum site, construction crews faced a problem as daunting as any battle: how to lift 6-ton blocks of travertine high above the ground, with nothing but muscle, timber, and rope. Roman engineers answered with treadwheel cranes. Giant wooden wheels spun by workers walking inside, their steps winding up thick hemp lines. Each crane could hoist a block the weight of an elephant, swinging it into place atop rising walls. Timber scaffolding rose in towers, lashed together and braced with crossbeams, forming a skeleton that grew with the structure itself. Capstans, vertical drums, turned by teams of 8, added extra pulling power, especially for the heaviest lifts. Reliefs on the tomb of the Hetairai show these machines in action, with dozens of men choreographed like a well-drilled legion. Every lift was a test of coordination. A single misstep could snap a rope or topple a scaffold. Yet day after day, block by block, the Colosseum climbed skyward. Every level of the Colosseum is laced with arches, more than 80 per ring, stacked in 3 soaring tiers. These arches do more than impress. They redirect the crushing weight of stone into the ground, turning pressure into stability. Between the arches, a mesh of groin vaults spreads the load sideways, so that no single wall or pillar carries the burden alone. This network creates a kind of structural redundancy. If one arch or vault cracks, the force shifts to its neighbors, buying time before disaster can spread. The corridors and entrances, called vomitoria, are woven into this mesh, channeling 50,000 spectators in and out without bottlenecks. Along the upper rim, 240 stone corbels jut from the attic, each anchoring a mast for the velarium, the vast retractable awning. Hoisting and controlling this canopy took the skill of naval riggers borrowed from Rome's own fleet. The entire system, arches, vaults, anchors, worked together, making the Colosseum more resilient than any single wall could ever be. The Colosseum's strength was always tested by forces it could not control. In 1349, a massive earthquake struck central Italy, sending shockwaves through Rome and slamming lateral forces into the amphitheater's arches. These sideways jolts cracked the southern wall and loosened connections that had held for centuries. Earlier fires had already stripped away protective plaster and scorched wooden supports, leaving bare stone exposed to rain and frost. Water seeped into the cracks, freezing and expanding with each winter. The network that once spread weight so evenly now faced stresses it was never meant to resist. Nature had found the first weaknesses, and the structure began to yield. Long after earthquakes cracked the Colosseum's shell, a different kind of damage began. Medieval builders saw opportunity in the ruins. They pried iron clamps from the walls, leaving empty slots where metal once locked stone together. Blocks of travertine and tufa were carted away to build palaces and churches across Rome. Each missing clamp and stone weakened the structural network further, turning a wounded monument into a quarry and sealing the fate of the southern wall. Every structure outlives its builders, but neglect outpaces even genius. Today, infrastructure everywhere faces the same test. Will we maintain what we inherit, or watch greatness erode? Share your thoughts below.